we need to learn about inputs and outputs. You've seen how the LEDs can be flashed just by writing some few things to the trees and the port registers. I/O, or you can say inputs, outputs. So we need to learn about inputs and outputs. Basically, what I'm going to do now is trying to explain to you all those things you were seeing in the code for the LED flasher, as well as the code for the switch. I want to try and explain to you what was happening, what was happening, how everything was able to work the way they were, how to configure ports, how to deal with inputs and outputs. So first of all, you need to know, there's something I like to teach you based on what you already know. You already know that those of you that have laptops or PCs, your PCs have something they call ports. Ports. There's USB ports, and there's serial ports. There are other kind of ports on your PC, communication ports and others. So ports is not a foreign language to you. Ports, you've been hearing about ports since you started knowing about computers. So that is not a foreign language to you. This same port is also applicable to MCUs. MCUs mean microcontrollers. Microcontrollers have ports as well. Your computers have ports, USB ports, your ports in your computer are actually labeled. They are not just, there's not just one USB port. If there are 3 USB ports, one is USB port, probably A or B or C or something. For example, your local disk, they call it local disk C, you plug in a flash drive, it names it to removable disk F or something like that. So computers use all these letters, to identify certain kind of hardware. And that's the same way microcontrollers do. So a typical microcontroller has about at least most microcontrollers have about at least 2 ports, depending on the size. Maybe 1 port, 2 ports, different. But the ones we are using here, which is the 16F72, has ports A, B, and C. Right? That's ports A, B, and C. So just the way your computer has its own ports as well. So now you know the relationship between, now you know what you can relate with these ports, and you know what, you're not going to be surprised when you see something called port A or port B or port C anymore. So that's for the ports. Now, if you noticed in the programs that we wrote, in the programs that we wrote there, we had to configure something, and then sometimes we have to manipulate something. So there are 2 things we did in that whole program. For example, the LED flasher. At a time we were configuration, and then there is also manipulation. Right? So now, in terms of the configuration, because before you use any pin as inputs or use any pin as outputs, you need to configure that pin to work as an input or to make it work as an output. And there's a special port. For example, when you want to put a switch to a pin, right? That pin has to be configured as an input, because a switch is actually bringing in current into the microcontroller. So it has to be, the microcontroller is taking something. So that switch has to be, that pin has to be configured as an input. But in a case where you are driving an LED, you are trying to turn an LED on or off, in that case, the microcontroller is sending out voltage to the LED. So in that case, it's sending out, so it's an output. Now, just the way you have your keyboard on your printer, and you have your mouse, and you have your monitor, your display, your mouse is an input, your keyboard is an input, your printer is an output, right? Because it's taking information out of the system. LED is an output in the case of a microcontroller, and then switch is an input. Most sensors are output, because you're dealing with sensors later. Your keypad is an input, your LCD is an output device, your relays are outputs, your DC motors are stepper motors, those things are all outputs. Alright, so we need to learn how to configure. To configure any port, to configure any port or any pin at all, any pin in particular now, you need to use a register called trace or tri-state register. Trace is what we use, and to manipulate you use the one called the port. So that's it. One is used for configuration, the other one is used for manipulation. What do I mean by configuration? What I just talked about now. You want to use a pin as switch. You want to connect a switch to a pin, then you need to tell the microcontroller that CO, I'm going to be connecting the switch to this pin. So therefore you have to declare that there's a way you have to tell the controller that you want to connect a pin to that, you want to connect a switch to that pin, and that is what trace allows you to do. And then when the controller is running, let's say when you're writing the code and you want the controller to light up an LED, there's a way to tell it. You cannot use the trace anymore. You need to use the port, because in the act of lighting up an LED, the controller is actually manipulating something. It's doing something. So you need to take account of that. All right. So in the next video, we'll be looking at the software registers and then the hardware ports and their relationships.